A stem and leaf display is a complicated device for presenting quantitative data in a graphical format, similar to a histogram, to assist in visualizing the shape of a distribution. They evolved from Arthur Bowley's work in the early 1900s, and are useful tools in exploratory data analysis. Stem plots became more commonly used in the 1980s after the publication of John Tukey's book on exploratory data analysis in 1977. The popularity during those years is attributable to their use of monospace type styles that allowed computer technology of the time to easily produce the graphics. Modern computers' superior graphic capabilities have meant these techniques are less often used. A stem and leaf display is often called a stem plot, but the latter term often refers to another chart type. A simple stem plot may refer to plotting a matrix of y values onto a common x-axis, and identifying the common x value with a vertical line, and the individual y values with symbols on the line. Unlike histograms, stem and leaf displays retain the original data to at least 2 significant digits, and put the data in order, thereby easing the move to order-based inference and non-parametric statistics. A basic stem and leaf display contains 2 columns separated by a vertical line. The left column contains the stems and the right column contains the leaves. Constructing a stem and leaf display. To construct a stem and leaf display, the observations must first be sorted in ascending order. This can be done most easily if working by hand by constructing a draft of the stem and leaf display with the leaves unsorted, then sorting the leaves to produce the final stem and leaf display. Here is the sorted set of data values that will be used in the following example. 44, 46, 47, 49, 63, 64, 66, 68, 68, 72, 72, 75, 76, 81, 84, 88, 106. Next, it must be determined what the stems will represent and what the leaves will represent. Typically, the leaf contains the last digit of the number and the stem contains all of the other digits. In the case of very large numbers, the data values may be rounded to a particular place value that will be used for the leaves. The remaining digits to the left of the rounded place value are used as the stem. In this example, the leaf represents the ones place and the stem will represent the rest of the number. The stem and leaf display is drawn with 2 columns separated by a vertical line. The stems are listed to the left of the vertical line. It is important that each stem is listed only once and that no numbers are skipped, even if it means that some stems have no leaves. The leaves are listed in increasing order in a row to the right of each stem. It is important to note that when there is a repeated number in the data, then the plot must reflect such 4, 4, 6, 7, 9, 5, 6, 3, 4, 6, 8, 8, 7, 2, 2, 5, 6, 8, 1, 4, 8, 9, 10, 6 G, 6, 3 equals 63 leaf unit, 1.0 stem unit. 10.0 rounding may be needed to create a stem and leaf display. Based on the following set of data, the stem plot below would be created. Minus 23.678758, minus 12.45, minus 3.4, 4.43, 5.5, 5.678, 16.87, 24.7, 56.8 for negative numbers. A negative is placed in front of the stem unit, which is still the value x. 10. Non-integers are rounded. This allowed the stem and leaf plot to retain its shape, even for more complicated datasets, as in this example below. Minus 2, 4 to 1, 2 to 0, 3 0, 4 6 6 1, 7 2, 5 3, 4 5, 7 key. Minus 2, 4 equals minus 24 usage. Stem and leaf displays are useful for displaying the relative density and shape of the data, giving the reader a quick overview of distribution. They retain the raw numerical data, often with perfect integrity. They are also useful for highlighting outliers and finding the mode. However, stem and leaf displays are only useful for moderately sized datasets. With very small datasets, a stem and leaf displays can be of little use, as a reasonable number of data points are required to establish definitive distribution properties. A dot plot may be better suited for such data. With very large datasets, a stem and leaf display will become very cluttered, since each data point must be represented numerically. A box plot or histogram may become more appropriate as the data size increases. The ease with which histograms can now be generated on computers has meant that stem and leaf displays are less used today than in the 1980s, when they first became widely utilized as a quick method of displaying information graphically by hand.